So this is 6.4b as in boy in college algebra, continuing on with polynomial equations. And so what we're doing is we're continuing to learn to solve these polynomials. Now this section has to do with using both graphs and algebra in order to find the answers. And again, the answers to these problems, and I can't emphasize this enough, the answers to these problems are where do the graphs cross the x-axis. Okay, that's the answer to these problems, because what we do is we make that equal to 0, and then we find out what values for x make our y, or make our p of x, equal to 0. And our values for x that make p of x or y equals 0 would be where they cross the x-axis. So remember, this number here pretty much tells you how many answers you're going to get, how many places this crosses the x-axis. It also gives us a good idea of whether we're done solving yet, because if we're solving for x and we get one answer, then apparently we're not done yet, because that 3 means we have, for the most part, 3 answers. Now it could be like the last example where we get, for our answers, -2, -3, and -3. We get 3 answers, but this one occurs twice, so really our answer is this with a multiplicity of 2. Okay, so we still got 3 answers, it's just 2 of them were the same, and that's okay. But it is key to remember that that exponent, that biggest exponent there, the lead exponent, gives us, or the degree of the polynomial, gives us how many answers we have. Alright, so we're going to use both graphing and algebraic methods to solve these. And the graphing makes it real easy to do so, because we just plug this equation into our calculator, and we can see from the graph, and you can see from bottom of page 469, figure 6.3, that it appears that the graph is going to cross at the number 1. Now we also know that it's going to cross 2 other times, but from this graph we know that for sure it probably crosses 1. Now we don't know that it's exactly 1. It could be 0.9 and it just kind of looks like it. So what we have to do is use algebra to figure out if indeed one of my values that crosses the x-axis is at 1. So what we do is we do our synthetic division, again, because it's very quick and painless. And this is just to find out if it does cross at 1. Okay, so we're going to put 1 there. So 1, 1, 10, 10, -600, -600, add those together, we get a 0. So whenever our last number is 0, that means that it works. So one of our answers is x minus 1. Okay. Now remember, we used 1 here to find out if this was a factor of this. Okay, because this 1 here means what number can I put in here that's going to give me 0. Okay, and that's why it's the opposite of what we have here. So we know that x minus 1 is one of our options. Okay, so what do we have left? We have a 1x squared plus 10x minus 600. Okay, so that's what we have left once we take the x minus 1 out. We factor it out. That's what we have left. And one of the things that you notice is it's easier to solve this, because you can solve this with quadratic, completing the square, or factoring, whereas this here you can't solve that way. So if we can lower our highest exponent from a 3 to a 2, that means it's a lot easier algebraically to go ahead and solve this. So what we've got here is x minus 1. and then we can solve this using factoring or quadratic. It doesn't really matter. Factoring is going to be the easiest in here because they are nice, easy to do numbers. So that means that my graph of this is going to cross at x equals 1, x equals negative 30, and at x equals positive 20. Those are the three parts that my graph crosses. Now, if you look back at the graph on page 469, because the numbers that we're showing in the graph are only to positive 10 and negative 10, it's not showing all the crossings. But if you look at page 470, 6.31, it shows you, because it makes the windows bigger in the graphing calculator, so you can tell that it is going to cross at indeed 3 places. It has 2 turning points, which it should, because 3 minus 1 is 2. What else do we know here? Crosses 3 places. Oh, and it's in the shape of a cubic function. Okay, goes up and down and up. And because this is odd, it has opposite directions. They both, the left side goes down, the right side goes up, and that's also because this is a positive here, and it's not flipped around. All right, so that gives us a real easy way to find our zeros of the equation, our p of x, or our x-intercepts. So the solutions that we're looking for is where the graph crosses the x-axis. So that's a nice way to do that. So let's look at example number 3. And example number 3 says that we've got a weekly profit for a product. So it gives us the equation. And this is another cubic, but it's got nasty numbers in here. Okay, it gives us that. Where x is the number of thousands of units. So if we get an answer like 4, that means x is 4,000. All right, so to find the number of units that gives break even, so we want to find out what number we put in here for x so that we get a break even number, so that our profit, which is what p of x means, is 0. We're not interested in a profit, we're not interested in a loss, we're interested in a break even where we don't make any money or lose any money, so p of x is actually going to be 0. So I'm going to go ahead and erase p of x, and I'm going to put a 0 in its place because that's our break even. So it says graph the function. So you're going to plug this puppy into your calculator, and it gives you, it says using a window representing up to 50,000 units and find one x-intercept of the graph. I'm just looking for one x-intercept, because if I find 1, it will take that down to x squared, which will be a lot easier to solve it than using the quadratic formula or whatever. Okay, so we put that graph in there, and we find out that we get a graph that appears to cross at x equals 20. Okay, so to find out if that's a true statement or not, we're going to use, again, synthetic division. So I'm going to put my 20 in there. Why did I not use a negative 20? Because because I don't have something like this. If I had that, I would put a negative 20 in there. But I don't. I just have this. So when x equals a number, the number you put in here for synthetic division is actually the number. Okay, so there's my numbers. I do the whole synthetic division. That would give me a negative 2, 9, 180, 100, 2,000. Add those together, get 0. And that's what I want. Okay, so good deal. Okay, whoops, this is, I don't know I put it there. Okay. So I get x plus 20, or I'm sorry, x minus 20. Okay, because that's a positive 20 that I divided here, so now I get x minus 20, because if I put this positive 20 in here for x, I get 0, and that's what I wanted. Okay, and there's what I have left. All right, what I'm going to do now is I'm going to take out that negative 0.1. I don't like it there. I don't like the decimal there. It makes it real difficult then to multiply. So I'm going to take that out, and that leaves me with an x squared minus 90x minus 1,000. Okay, and you can get these answers by, when you factor that out, you divide that by that, and you get 90. 100 divided by negative 0.1 is a negative 1,000. Don't forget the signs change because you factored out a negative. Probably need to make my little brackets here. All right, so that leaves me with that. All right, let's go ahead and put that up here. I'm going to use black, and actually I'm going to put that in front. And then I don't need all the brackets and stuff. Oops. Okay, don't know what that came from. Oh, my X. Okay, so I have that there, and then I need to factor that out. Okay, so this factors to x minus 100 and x plus 10, because 10 times 100 is negative 1,000, and negative 100 plus 10 is negative 90, so that works, giving me x minus 20, negative 0.1. Okay, so my answers are crosses at those three places. Okay, so those are my solutions. So those are the zeros of my function. Now it says determine the levels of production that give the break even. Okay, so the break even happens at 20 and 100. Negative 10 works, but you cannot have a negative number of units produced. So if you produce 20, you break even, and if you do 100, you break even. Now remember, these are in thousands, so 20,000 or 100,000 units give a break even. Okay, so that's it for example 3. All right, so we're going to look at some things with the rational solutions test, which the book doesn't go into a lot of detail, so I'm not going to go into a lot of detail, but I do want you to understand what's going on here, and we'll save that for 6.4C.